Good morning, my students. Now we will discuss about different types of waves, wave velocity and audible sound. Now for propagation of sound, a material medium is required, and before propagation of sound have to be produced, and for production of sound, first the sounding body vibrates. After vibration, waves are formed. And there are two types of waves. One is longitudinal wave. And the second one is transverse wave. Now we have to know what is longitudinal wave. Actually, sound wave is one type of longitudinal wave. Now, longitudinal wave is the wave in which the wave particles oscillate parallel to the direction of wave. Say there is a spring. During elongation of spring, the oscillation, this is oscillation, and this is the direction of wave. That is, oscillation takes place towards the direction of wave, or oscillation takes place parallel to the direction of wave, and this is called longitudinal wave. So in a nutshell, longitudinal wave can be defined. It is defined as the wave in which the oscillation takes place parallel to the direction of wave, and sound wave is one kind of longitudinal wave. Sound wave is longitudinal wave. And now transverse wave. Say this is water, and if you throw a stone on water, the water oscillates and wave is formed. This oscillation of the wave particles is perpendicular to the direction of wave. This is direction of wave, this is direction of wave, and this is the direction of oscillation. So if the oscillation of the wave particle is perpendicular to the direction of wave, oscillation is AB and wave is AC. So AB is perpendicular to AC. This type of wave is transverse wave. And light waves are transverse wave. Light wave is one kind of transverse wave. In our practical life, we see when a stone or something is thrown on water, wave forms, and that is water waves are transverse waves. And waves in the spring, that is when the spring is elongated, as the wave formed is longitudinal wave. And these are two types of waves, so keep in your mind that sound waves are longitudinal waves and light waves are transverse waves. And also there are two types of waves, that is, one is elastic wave and one is electromagnetic waves. Sound waves are one kind of elastic waves. Elastic waves these waves cannot propagate without the help of any medium, and this sound wave cannot propagate without the help of medium. And the electromagnetic waves, electromagnetic waves can travel without the help of medium. So light coming from the sun, these light waves are one kind of electromagnetic waves. X waves are electromagnetic waves, and gamma rays waves are also electromagnetic waves. they don't require any medium for their propagation, and they moves with very high velocity. Now these are regarding waves, and now what is wave velocity? Now we have to know what is wave velocity. Wave velocity is the velocity of wave in a medium, that is the distance covered by wave in 1 second is speed of wave, and displacement covered by wave in 1 second is velocity of wave. So the wave velocity in a medium differs on the quality of the medium or characteristics of the medium. There are three types of medium: solid, liquid, and gaseous medium. In solid medium, the wave velocity is maximum. In liquid, it is medium. In gaseous, it is minimum. And in our surroundings, air is a natural medium. In air medium, the velocity of wave in air velocity of wave equal to 332 meter per second at 0 degrees Celsius. Underline C, 0 degrees Celsius. That is, wave velocity in air or in any gaseous medium depends on temperature. With the increment of temperature, velocity of wave, sound wave, increases in a gaseous medium. And it has been found that with increment of with the increment of 1 degree Celsius temperature, velocity of sound increases by 0.61 meter per second in air. So when temperature increases, velocity of sound increases in air, and with the increment of per Celsius degree temperature, velocity of sound increases by 0.61 meter per second in air. So in the summer, velocity of sound will be greater than the velocity of sound in winter in the air. If it is asked what is the velocity of sound at 40 degrees Celsius in air, 40 degrees Celsius in air, the velocity of sound will be 332 plus 0.61 into 40 meter per second. That is equal to 332 plus that is 350.4 meter per second. Sorry, 356.4 meter per second. That is, at 0 degrees Celsius, velocity of sound is 332 meter per second. At 10 degrees Celsius, it will be nearly 338 meter per second. At 40 degrees Celsius, it is 356.4 meter per second. So with the increment of velocity, increment of temperature, velocity of sound increases in air. Now, in a liquid, velocity of sound is much greater than that in air. In water, velocity of sound is nearly 1500 meter per second, and in solid, say in iron, velocity of sound is nearly 5000 meter per second. So it is clear that sound travels faster in liquid than in gas, and it travels faster in the solid mediums. And if you take certain long tube, it will be better a hollow iron pipe. Say in this manner, it's a hollow iron pipe, and at one side A makes a sound, and at another side B hears the sound two times. Initially he hears the sound, and after some time he hears the same sound. The same sound is repeated. This happens due to maximum velocity of sound through the iron medium, and through iron medium sound reaches first, and in vacuum medium, that is in air, sound reaches low. So the same sound is heard two times by the listener B, which is produced by the producer A. So it is clear that velocity of sound is much greater through solid than through vacuum. Now, audible sound. Audible sound have a particular frequency. Audible to human beings. Audible means audible to human beings. Its frequency will be 20 Hz to 20,000 Hz. Audible sound. If the frequency of the sound lies between 20 Hz to 20,000 Hz, that will be heard by the human beings, and this is the frequency range of the audible sound. And what is the sound frequency below 20 Hz? That is subsonic sound. Subsonic sound has the frequency below 20 Hz, and ultrasonic sound has a frequency greater than 20,000 Hz. And if the frequency of the sound be below 20 Hz or greater than 20,000 Hz, those will not be heard by the human beings. This is audible sound, but keep in mind that which is non-audible to human beings, that may be audible to other animals. For example, bats can hear the sound above 20,000 Hz frequency, that is, which is ultrasonic to human beings, that is not ultrasonic to bats. Bats can hear it, and they produce a sound having frequency greater than 20,000 Hz, and this sound moves towards the fruits, and after reflection, bats can hear the sound and can detect the position of the fruits and can take it. And now, last, we will see on which factors does the velocity of sound. Factors on which velocity of sound in gas depend. Factors on which velocity of sound depends in air. Number 1, temperature. Of the gas. Number 2, density of the gas. Number 3, humidity of the gas, and it does not depend on, it will have to be noted, it does not depend on pressure. But we have to mention the pressure, because anything regarding gas, if we like to mention anything regarding gas, we have to mention pressure. Without mentioning pressure and temperature, we cannot mention the volume. But in this case, pressure, velocity of sound does not depend on pressure. Now, what is the effect of temperature on the velocity of sound in gas? When temperature increases, velocity of sound increases. I have already stated. Now, density. When density of gas increases, velocity of sound decreases. Actually, the relation is that V proportional to 1 by root over D. That is, velocity of sound in gas is inversely proportional to the square root of the density of the gas. For example, the vapor density of hydrogen is 1 and vapor density of oxygen is 16. So vapor density of oxygen is 16. So the square root of vapor density of oxygen is 4. So velocity of sound in oxygen will be 1 by 4 part of that in hydrogen. In oxygen, I am again saying vapor density of hydrogen is 1. Vapor density of hydrogen equal to 1 and vapor density of oxygen equal to 16. Therefore, root over D of oxygen equal to 4 root over D of hydrogen equals to 1. So, root over D of O is 4 times than root over D of H. Therefore, velocity in oxygen will be 1/4 of that in hydrogen. So velocity of sound in oxygen will be 1/4 of that in hydrogen. Therefore, it is clear that velocity of sound decreases when density of gas increases. And the third point is humidity. When humidity increases, velocity of sound increases. So, in humid air, velocity of sound will be greater than in dry air. Fourth point, pressure. There is no effect of pressure on the velocity of sound, and this can be explained from Newton's law and Laplace's correction that will be discussed later on. And this is all about velocity of sound and audible sound. Thank you, my students. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.